Hey everyone, how's it going? We're going to try and do a sub 5 RAG overview. And I already stumbled a little bit, so let's get right into it. So this can be focused on a non-technical. You don't have to be an engineer to understand what's going on. I'm certainly not. And so that's going to be really the kind of main point here. We will look at a little bit of code just to give you an understanding and just share a lot of freebies throughout. So what is RAG? Retrieval-augmented generation. Basically, it's a way to give LLMs additional knowledge, whether that's up-to-date news, internal docs that's not in the training set, in addition to your prompt. So we all know once LLMs are trained, they're kind of frozen, right? Like they don't get continually updated with new information. That's why we need to give it to them. So for example, public companies will produce NKs every quarter. And so if we wanted to know about Google's last quarter, we'd have to send a prompt like, hey, how's last quarter? And then pass the relevant 10K data. And so RAG lets us give the model additional knowledge, in this case through this kind of variable here, and we'll be retrieving it. So we're not just kind of pasting in a prompt, we'll be retrieving it from a vector store. And this won't be the video where we talk about whether RAG is good, RAG is bad, and we'll do another kind of video on that soon because I do have some opinions there. Right now, I'll just be giving an overview. So we will start as complex and then go make it a little bit more simple. Also, if anybody knows how to get rid of this thing in FigJam, please let me know. So when a user query comes through, so like something about Google's 10K, how much revenue do they have in their cloud business? In RAG, what will happen is that message will be translated into an embedding. And an embedding essentially is just a numerical version of the word. So it'll be translated to a vector embedding. Those embeddings exist in a vector space where you have words that are related, are near each other. And so this will come back soon. But we see for the word dog, the nearest point is dogs, and then cat, and then so on and so forth. So English goes to tokens, goes to vector embeddings. Up top here, we have data. So this would be maybe all of the 10Ks. If this is like a Google specific application, it's all of Google's 10Ks. If it's a application for all of tech companies, it'll be all the tech companies' 10Ks. Those will be chunked. So basically just kind of cut up and turned into embeddings. And then those are stored in our vector database. So the vector database stores embeddings. And so then our query will go into that vector database, and they'll probably do something like a semantic similarity search where we're looking in this kind of vector space and seeing, okay, here's Dan's query. What is it close to? What data is around it that we can pull from and include as context? And then so it would go in there. It would find data related, or embeddings related to Google's recent 10K. Then that would come out as chunks. The chunks are like the English portion. So then the chunks and then the actual direct query are passed to the LLM. So it's a couple steps. So the first step is getting all that data, chunking it up, having the embeddings created, storing that in the vector database. So this is something like Pinecone, for example, is a very popular vector database, and they help kind of with all of this. And kind of simplifying it, a question will go to the LLM and it will be supplemented with relevant information from the vector database. And I kind of give a little bit of a shrug because the relevancy of that data is really kind of up to you. There's a lot of different methods in terms of how many chunks you want to receive. Do you want to do semantic similarity? Are there other types of comparisons between your embeddings and the embeddings in the vector database that make more sense? But that's a brief overview. A couple of examples where RAG is like potentially helpful. So if you have a customer support bot, you have a really long conversation, maybe that conversation eventually is too big for the context window, you need to start to manage that in some way. So maybe you're only getting the information relevant to whatever the user is talking about. As we talked about before, accessing internal knowledge bases. So you don't, or excuse me, I mentioned this before. So let's say you want to have an LLM that can, has access to all your docs and PowerPoints and things along those lines. You wouldn't send them with every single prompt. If I'm just asking about a specific, analytics report from 2025, I don't need to know about all of our HR policies. So it will be smart enough to go get the correct information there. And so what's nice is you can update the data in the vector database in real time. So in that other example, we can add more 10Ks over time, and that's all still stored in the same place. It's adding to that database. And as I mentioned, we can upload those in real time. And for that finance example, if you just had that user query and sent it to the LLM, it wouldn't know about Google's most recent 10K because none of the models are that up to date. So in this case, we have all the 10Ks stored in the database as embeddings, and then we pull out just that specific information related to Google's embeddings and related to the user query about revenue for the cloud business, and that's what gets sent to the LLM. And we'll look at a very quick code example, and then the example code will be below as well, so you'll be able to get that. Oops, I'm gone now, but let's move me a little bit. Okay, that's fine. So this is all you need. We're using LlamaIndex, and then this will essentially be all you need to just stand up a quick RAG if you want to do some testing, a RAG pipeline. So in v5, let's just has my OpenAI API key stored in here. We're going to import some modules from LlamaIndex, so a reader that will load docs from our project, the PDFs. And then the vector store index will create the index for its documents into the index. So reads the docs, which are stored in our data folder here. It's a bunch of PDFs, and then we'll create the embeddings. We use OpenAI or O3, and we're using OpenAI. Read the documents that are in the data folder. Again, these are just a bunch of recent research papers I've been reading. Give it a query, and then query the index to get a response. The query engine, which is a couple of lines up here, converts the text into an embedding, and then retrieves the most relevant document chunks from the index. It does semantic similarity search here, and I get the answer. And so this is the basic setup, something that I actually ran into, and we'll touch more on this in a video about should you use RAG or not, is you can see the question here, give me 2 takeaways from each article. It doesn't really work in terms of semantic similarity. So this query was actually making the model hallucinate and thinking of other papers it just has in its training data rather than focusing on the data stored in the papers here. So that's another thing to think of, is like, what are the types of questions that are coming through? Is it going to have the right information for whatever your pipeline is currently set up to do to go get that info? If I was maybe talking specifically about the names of the papers, that obviously would be much more helpful for the article. But when we run this, it doesn't really work super well. That's something that's really important to think about and keep in mind. And we'll be covering this kind of more, but this is just a general overview. Code's below, examples are below. Go set up your own pipeline, start testing it out, see if it works for you, and we'll see you next time.